Highlight search hits and show concise snippets with highlights. By the end, you will have a small Python snippet pipeline that finds matches, highlights query terms, trims context windows, ranks results by hit counts, and returns the top K highlighted snippets. You will see how adjustable parameters change focus and performance. I'm Professor Pi, teaching search and IR from basics to advanced in simple Python. Why this matters. Highlighted snippets are how users judge relevance at a glance. They optimize click-through and relevance perception, tied to a core metric like precision at 1. The trade-off is snippet length versus information density. Short snippets save screen space and reduce load time. Longer snippets increase context, but cost a bit more rendering and attention. At scale, focusing highlights can cut average time to relevance by noticeable amounts. Search results snippets make it easy to scan. They shine when documents are long and queries are short. They struggle with semantic matches that need paraphrase. For literal term matches, a small regular expression approach is fast and robust. We will build a tiny practical pipeline that highlights terms and documents, trims context around matches, ranks by frequency, and returns top highlighted snippets. Now we will create the initial find and highlight step. This snippet highlights query terms in the first matching document. It stores 3 short documents in a list named docs and a multi-word query in the variable QRY. The pattern pat joins the query terms with an OR and compiles a case-insensitive regular expression. The next function walks across docs and picks the first document that matches the compiled pattern. The substitution operation wraps any match term with square brackets to make hits visible. If a term appears multiple times, they all get bracketed within that document. The printed string confirms the first hit and shows how highlighting will appear. Next, we will extract focused context around a match. This snippet extracts a short context window around the first match. It builds a longer text from the third document so we can show trimming. The search uses the compiled pattern search function to locate the first hit, and span returns the start and end offsets. The tuple win computes a fixed window around that hit while protecting boundaries with max and min. Slicing uses win to cut text, and the pattern substitution inserts brackets only inside the window. This keeps snippets compact while still pointing the reader to the highlighted term. The printed substring shows focused context, which is ideal for search previews. Next, we will rank documents by how often they match. This snippet ranks documents by hit count and shows the top 2. It counts matches per document with the pattern find all function and stores pairs of index and frequency in a scores list. The sorted call orders by descending count, then by index, so ties are deterministic and reproducible. After selecting the first 2, the list snips is built by applying the pattern substitution to each chosen document to highlight matched terms. This makes both the ranking and the display consistent across runs. The printed list shows the strongest matches in order, with visible highlights that guide the eye. Now we will trim the top result to an adjustable snippet window. This snippet trims the top result to an adjustable snippet window. It selects the best ranked document from the top and finds the first hit using the compiled pattern search. The span offsets S and E define where to center the snippet. The variables left and right clamp a W character window around the match, and ellipses are added if content is trimmed on either side. The pattern substitution call highlights only within this window, keeping the preview short. Increasing W shows more context, but lengthens the snippet and perhaps noise. Decreasing W tightens focus and reduces length. The printed line shows a concise, highlighted preview. Next, we will efficiently get the top K results without a full sort. This snippet retrieves top K results using a heap for efficiency. It builds tuples of score, negative index, and index, so ties break by the earliest document and relevance sorts correctly. The heap n largest function pulls only the k most relevant items without fully sorting the entire list. Then res formats those picks by applying the pattern substitution to highlight match terms in each document. The variable k controls how many snippets you show. Larger k returns more results but costs a bit more time and memory. Smaller k is faster and keeps output short. The printed list presents final ranked highlighted snippets ready for display. Recap. 1. It is a lightweight pipeline that finds literal matches, highlights them, trims context, ranks by hit count, and returns the top K highlights. When to use it. When your queries are mostly keyword-based and documents are long enough to need previews. One caveat. This literal approach misses semantic matches and paraphrases. Next step. Tune the snippet window and the top K parameter while measuring user click-through, or a simple precision at 1 metric to balance focus and context. If short practical IR helps your projects, subscribe and watch the rest of the search videos.